Good. Okay, welcome everybody. You are at the National Student Data Corps Data Science Career Panel in August 2022. We're delighted you joined us. We'll be starting in a couple of minutes at 3 o'clock Eastern. And we are streaming live on YouTube, I believe. So if you have any friends that want to watch us on YouTube, they can. In the meantime, if you like, you could actually go to the Nsdc Slack channel, and maybe Emily or Lauren could put the link in the chat in case you would like to go there and meet other friends in the National Student Data Corps. We have great speakers today, and we're super excited that you could join us. And whether it's good morning, good afternoon, or good evening, we're really happy you're here, since this is a global community. And so in the chat, we'll be starting in 2 minutes at 3 o'clock Eastern. You can see that we have the Nsdc Slack channel link there. And you can also share with your friends that they can watch us live on YouTube on the Northeast Big Data Hub YouTube channel. And that link is in the chat as well. During the webinar, you'll have the ability to put questions in the Q&A section, and we really look forward to your questions. There are a number of students that have already sent us some questions, which we'll be using as well. So we'll have a mix of live input that we will transmit through the webinar, and then also some questions that came in ahead of time. So if those users and students and parents and teachers and professionals aren't able to join us live today, they'll be able to watch the recording on YouTube as well. So we have 1 more minute. Grab your popcorn. We'll get started soon. Okay, it is 3 o'clock Eastern, and so we'll get started. Some other people might be coming in during the session, but since you're all here and we want to be punctual for you, thank you very much for joining us at the National Student Data Corps August 2022 Data Science Career Panel. We do these panels every couple of months. We started them in February of 2021. We've had a couple thousand people join us either live or via YouTube, so we're super excited to meet the new ones that haven't been here before, and those who are coming back to hear more new and exciting journeys in data science. So our moderators today will be myself. I'm Florence Hudson. I'm the Executive Director for the Northeast Big Data Innovation Hub, and actually the founder of the National Student Data Corps. And we'll tell you a little bit more about the history in a few minutes. And then our other moderator is Emily Rothenberg. And Emily is the Nsdc Program Coordinator. She just joined us last December, and she's incredible. She's done so many cool things for us. And it grew so much from nothing in February of 2021 to almost 3,000 people today. So we needed someone to help us, and Emily joined us, and she's doing a wonderful job. Our panelists today, we're really, really lucky. These are some incredible people. We have Manyank Varia from Boston University. We have Steve Horne, Vivien, Bonazzi, and Yu. And so what we try to do is give a nice mix of academia, professional, years of experience, perspectives. And so we're super excited that they can be with us today. So our agenda today is we'll give you a little overview of the Nsdc. Then we'll have our panel discussion, what you really came here for. Then we're going to talk a little bit about some of the resources that are available through the National Student Data Corps, open, online, free resources available 24/7 all over the planet, which I think is one of the reasons that it's a global community, because people can access it all the time, anywhere. We'll talk about Learner, Educator Central, and career development resources. We'll talk about our chapters program, which was actually created by a student who asked for a chapter, and we said, okay, I guess, and now we have a dozen around the planet, 6 in India and 6 in the US, and we're always looking to create more. We'll talk more about that. Emily will help us with that. And then we'll give you a little update on the inaugural Data Science Symposium that we've been having this year. And then we're going to have open Q&A. And so we encourage you to put your questions. You can see a little Q&A button if you hover at probably the bottom or the top, depending on what your screen looks like and what type of device you're on. And you can put your questions in there. And we'll have open Q&A for probably about half an hour at the end after the panel, so that we can answer your questions of interest. So first, a little bit about the Nsdc, a little background. So it's led by the Northeast Big Data Innovation Hub, which is funded by the National Science Foundation in the US. It's a program that began in 2015. We got another amount of money in 2019. We actually just got our last $1 million for our final year yesterday from NSF. And we have programs across these 4 focus areas: education, data literacy, health, urban rural communities, and responsible data science, including security, privacy, and ethics. And what the hub does is we leverage our role as a community convener and collaboration network to fuel data science innovation through diverse and inclusive partnerships, working through the Nsdc to increase data science capacity and talent with a focus on underserved communities. What happened was when I took this role as executive director, I was on the advisory board and steering committee and leadership teams since they were born, the hub, in 2015. But 2 years ago, they asked me to come and be the executive director. And I looked around and I said, you know what? There are so many students who don't even know that data science is a thing. They don't even know the words data and science go together. They have no programs. They may not be in school right now. Their teachers aren't teaching it because it was kind of new. It's still kind of new. So we decided that we wanted to try to create a program to increase awareness in education and data science. So we went to our community, the Northeast Big Data Hub community, which is now over 6,000 people, and asked for founding committee volunteers. And what was really interesting is 24 people said, sure, I'll volunteer. They said, wow, that's really cool. So I guess this is a good idea. And so then it became a community developed initiative. They helped us create it that provides resources and opportunities for students to learn data science. And it includes learner materials, educator materials, video libraries, Career Central, a Slack channel, and we keep growing it. And so the founding committee signed up for 3 different teams. So we have a content and pedagogy team. So they helped us create and curate the material that's in Learner Central and Educator Central, which Emily will be showing you later. These are professors, not-for-profit executives, a librarian, students, and someone from IBM. IBM actually, I'm a former IBM executive, and one of the IBMers actually basically donated the IBM Open Data Science for All content on GitHub, and we use that to create videos that our peer instructor and mentoring team creates. And so we have videos of the dry, like PowerPoint content, so that people can make it come to life. And so we have the peer instructor and mentoring team and the outreach team. And so together, they've been building this incredible National Student Data Corps community. It started out as the Northeast Student Data Corps, since we're the Northeast Big Data Innovation Hub. And we created the founding committee from the Northeast community. And then we did our first event in February of 2021, and over 700 people enrolled. And before we knew it, we had thousands of people from all across the US and 20 more countries. We were like, oh man. So we went from Northeast to national with an international reach. And now we're thinking about if we should be rebranding as global, which is kind of cool. So we now have over 2,900 members. And as you can see, it's all over the world. And we're so excited that it brings value to so many students around the planet. So that's a little bit about the Nsdc, born as the Northeast Student Data Corps, evolved into the National Student Data Corps. And we have these incredible panels. And we're so lucky today that we have Manyank Varia from Boston University, Steve Horne from Bridge, Vivien Bonazzi from Deloitte, and Yu from BlackRock. So I'm going to stop sharing my screen, and I'm going to hand it over to Emily Rothenberg. And so she's going to moderate our panel, and she'll be bringing up questions, telling each of the panelists, take 3 minutes to do this or 4 minutes for this question. And so these are the questions that have been submitted before. And so we're going to go through those, then we'll go through more material in the open Q&A at the end. And during this time, feel free to put your questions into the Q&A. You can just hover over the button and you'll see that there'll be an opportunity to put your questions in there. So Emily, take it away.
Thank you, Florence, for that great introduction, and welcome, panelists. We have a really great lineup for the panel today, and we're very excited to get started and continue this conversation. I'd again like to remind all the attendees that Q&A box is open. We can ask the panelists your own questions, so that would be great. And with that being said, let's begin the panel portion of this event. So for question one, all panelists will respond, and each will have approximately 3 minutes for their response. Question one asks, please tell us about your data science journey and what excites you about data science. So Manyank, would you like to start us off?
Sure. Hello. My name is Manyank Varia. I'm an associate professor at Boston University. My background to data science is a long and twisting journey. Maybe similar things other people in the panel will say as well. I've worked in academia my whole career. So my undergraduate degree is in electrical engineering, my graduate degree is in math. I've worked in the computer science department for a few years before now being a part of Boston University's new data science unit, where we have undergraduate and graduate degree programs. One of a growing number, not every university does, but a growing number of schools have data science curriculum at the college level. So my own personal research background is in cryptography and designing systems to allow people to work with data that they cannot see, and to design ways that even if data is encrypted or encoded, you can still do data science computations over them. And so my own personal background is in skills that kind of don't have any direct connection to data science, but has sort of I've moved into this space over the years, I guess I'll say. And so what me and a bunch of us at Boston University do is design systems for protected data science, for allowing computations that would be difficult to do for data in the clear. So for example, we've had a long-running collaboration with the city of Boston to do measurement of the gender and racial wage gap across the greater Boston area, to measure from real salary data to calculate just the aggregate pay disparities across the city, but to do it in a way where neither we nor anyone else gets anybody's actual salary information, and yet still using the power of cryptography, we can calculate the answer anyway. And so this is a field of study in cryptography that's been going on for many decades, but as both the field has matured and the world has become more data-driven, it's slowly but surely morphing into colliding with the data science realm. So that's sort of my journey.
Thank you so much for sharing. It's very interesting to hear, and I'm sure a lot of our attendees will like to hear about how sometimes it's not just a 1, 2, 3 step right into the data science field. There can be some twists and turns along the way. So thank you for sharing. Vivien, would you like to share about your experiences?
Sure. Hi, I'm Vivien Bonazzi. I work at Deloitte and I'm a biomedical data scientist. So a little bit like Manyank was talking about, we all have different twists and turns. So I'm actually trained as a biomedical scientist. So I have an undergraduate, master's, and a PhD in biomedical sciences. But I started coding when I was 15. So I was good at math. I understood computers fairly well. And it was pretty obvious to me that you could apply this to science. So I was this kind of hybrid of these two. It's still a little odd, but the field is called bioinformatics or computational biology, and it blends the use of data science with the understanding of the content knowledge. My background is in genomics and proteomics as well, so I apply what I do to the study of genomes and proteomes. And for most people, if they don't have that much background here, they probably did hear of the Human Genome Project, which was done way back in 2000, which makes me feel very old now. But I came to the United States from Australia originally, and essentially I was looking at the application of computing to biology, and that organization that did that both in the government and the commercial space was looking for people like me that had this background of computer science, but really strong knowledge of biomedicine. So that's kind of me in terms of what I do. My first job was essentially doing kind of consulting for academics in the lab as a way to make my my way through graduate school. So you had a science problem that I needed to apply my knowledge of data science. So I would do your analysis, and in return, for those of you who do science, I would do your analysis and fix your computers, and in return, I would get things from your lab. So I created this big bartering system inside Australia. I was also fortunate to work at the Australian National Genome Service whilst I was a PhD student, and that was, I guess, my first job that was paid at a richly sum of about $100. It was exciting. So I think one of the questions is, what do we do? It's exciting to do this work that combine these fields for me. It is still difficult in a lot of ways to make your way through this. A lot of people are pure data scientists. I think I'll let others describe that. I'm this sort of hybrid mix. A couple of things about my journey, just to wrap it up. What do I love most about my job? It's very different every day. I love helping people solve their problems. And in the case of biomedicine, it's solving problems at scale, because I use computing technologies and methods to apply this to that data. What else would I say here? Work-life balance came up as a combination there. You could work as many hours as you want in this field. You never run out of things to do. And I predict long after I retire, there will be lots of really interesting things to do. The field is maturing, and it's been around, I'd say, in my world, probably 25 years or so. I came into it it had already started, but I predict there'll be lots of opportunities. So if you want to combine these two fields, there's a lot of opportunity there. And I'll stop there and hand it on to somebody else.
Thank you so much. I think a big portion of our audience is also very interested in health, biology, bioinformatics, how they cross over. So I'm sure you'll get some questions later in the webinar about your experience. So thank you. Steve, would you like to go?
Sure. Thank you. Can you hear me okay?
Yes.
Yes.
Perfectly.
Okay. So I'm kind of the fossil here of this group. I've been around data forever. Give you a little background of my experience. When I was in 8th grade, I lived in a town that was right near where Bell Laboratories, the original place where they invented the laser and the transistor and a lot of other neat things was. That's churned over since then. But one of my neighbors brought home a computer that he had at the office that they didn't need anymore, called a PDP-8. It was a DEC computer. Now, you think about laptop computers and things these days. This thing was about the size of a refrigerator and had a keyboard that sat in its own stand, and it used paper pieces of tape that I kept in a film canister so I could code. So the first coding exercise I did was using a language called assembler way back when, and I built a little program when I was in 8th grade that I could actually do something. There's a game that was created called Pong, where you had these little paddles on each side and you could hit the little dot on the screen back and forth. Well, I made a piece of code. It was pre-Pong. So it was pre-Pong, where the computer would serve up the little dot, but you'd hit it, but then it would go off into oblivion. So that's all it did. So it was one hit and you're over. So, but that was on the piece of paper tape that was about 8 feet long that I used to originally code. When I was graduated college. Actually, I didn't graduate college. I was still in college. I was working full time, and I ended up starting at Dun & Bradstreet, which is a business-to-business data company. So I'm more on the commercial side, different than Manyank, who's been mostly on the academic side. I started in the commercial side, and I learned data science and statistics because I took a course while D&B sponsored me at NYU, and I ended up going for my graduate degree in both direct marketing and statistics. And at that point in time, data science was called statistics. This is in the early 80s. And I invented a number of different products and services that were built as models or statistical algorithms that were driven off of the data we had. I left Dun & Bradstreet in 1999, so I was there for 21 years. And I ended up becoming the head of marketing services and ultimately marketing sciences and the CTO at a very large advertising conglomerate. At that point in time, the largest in the world, which was called the Interpublic Group of Companies. I worked there for several years, formed a marketing services business called Analytic Eye, which we did a lot of analytics and processes for companies to help them understand their customers, understand who was in the marketplace. I ended up going into investment banking to buy and sell marketing and data analytics firms. I did that for a number of years, sold one of those firms to Dow Jones. And at that point in time, Dow Jones was looking for me to database the news. They wanted to use its new machine learning language called natural language programming, or process called natural language programming, to understand using a computer what paragraphs said in financial statements. So who was the party, who was the counterparty, what was the dollar amount of the transaction, all this information that would be written out in text, but the computer could read it and turn it into a database accessible process. Well, my favorite person of the time, Rupert Murdoch, who I ended up working for, and I say that kind of tongue in cheek, he's a difficult person to work for, said to me, "You're going to work directly for me. And I don't want you to do this databasing the news. I want you to find dirt. I want you to find information about companies and what they're doing and everything else." So I began to research information on all the trades and exchanges and all these new products called derivatives that were occurring in the marketplace that nobody seemed to understand. And being from the data world and understanding data, I kind of got it pretty quickly. And I began to see patterns in the data that were somewhat disturbing. And this was in 2007. So Murdoch, seeing what I presented him, asked me if I would go down and meet with the chairman of the SEC, the Securities and Exchange Commission, which I did. And he said, "Well, tell me what's going to happen." I said, "Well, the banks are having problems. They're going to have some real issues." And he says, "Well, where do you see this happening first?" And the first one that I saw the biggest problem with, which was Bear Stearns, he says, "Well, they're reporting their earnings next Thursday. Come back to my office and we'll sit down and watch their earnings call while you're sitting here in my office." So I'm sitting there next to him. And the guy comes down as the CFO from Bear Stearns and says, "We're $16 billion in the black." And he looks at me, he says, "Well, your algorithm stinks." Okay, so that doesn't tell me anything because you said they were going to have problems.
So Steve, I hate to butt in, but
Am I coming over my time?
yeah, you're over already.
Okay, so let me just finish up saying I ended up becoming the consultant to Congress for TARP and transparency because of that, because I actually found out the algorithm did work and we found out the banks were in difficulty. Worked at IBM. Today I retired and I went back to consulting, and now I'm working for a company called Bridge that does marketing information. So
Okay.
give you a little bit of background and stuff. I've been in the data science business forever. So we can talk about more of that later on. Thank you.
Yeah, and we'll be able to do that. There are a bunch of questions. You could look at the Q&A if you want to answer any of them, in there. We're going to be answering some of them live. Thank you very much. I know how you feel when you've been around forever. It takes you a long time to explain it. So thank you for sharing so much of that with us, and a lot of the twists and turns and the hills and valleys and all of that. So thank you. Okay, Emily, back to you.
Yeah, and would you like to finish up the question?
Sure, happy to be here. Thanks for inviting me. I currently work at BlackRock, providing data science support to their sales teams who distribute asset management products and software products. I was originally an academic. I was a professor, assistant professor of marketing in business school for a while after PhD. But I realized in marketing or in academia in general, there are a few lucky ones who have strong connection to industry, but most of people just cater towards their peers, try to publish papers, but establishing real impactful projects with industry is somewhat difficult, especially with social science disciplines. So I entered the financial services area from 2015 onwards, and I have been since serving at various financial institutions such as AIG, Point72, which is a hedge fund, Bank of New York Mellon, and now at BlackRock. What I found interesting in the data science career is, like some of our panelists mentioned, it provides you an opportunity to do consulting, because usually data science is considered a tool. It usually doesn't stand on its own. It helps other people with substantive problems to solve their problems. So we come across as a technical partner and expert. And every time you solve a problem, your other counterparty provide the raw material, but you have a lot of leeway to shape the problem and shape the solution. it's a co-creation process, and every time you learn something that you didn't know before. And to make it even better, you see the solution come into real life and make impact to people, to the world. So that make it interesting and meaningful.
That's amazing.
Yeah. Sorry,
Yeah.
Mars, do you have something you want to comment on?
Yeah, I just wanted to mention you. That's really exciting. I just wanted to share that, you know, as we listen to all of you, one of the things we talk about is data science for good. What are you doing that's valuable with data science? And you're all talking about things like that. I think that's so exciting. And in so many different disciplines, you know, Manyank, you're talking about leveraging your techniques, which I know some people call secure multi-party computation. For those of you who want to impress people, when you see them at the bus stop, it's secure MPC. And, you know, working on diversity, equity, and inclusion issues, you know, regarding wage gaps, you know, in the city of Boston, how cool is that? Vivien, you're working on, you know, bioinformatics and biology and genetics and genomics and things that can help keep people alive or help them, you know, be cured faster. It's amazing. Steve, you've helped people try to figure out that there's risk they're not aware of, you know, surprise, right? Especially non-intuitive clarity, I call it, you know, where they look at it and say, that can't be. Like your algorithm is wrong. And I'm like, well, yeah, we'll see, you know, and you were right, right? And then it's so cool that you actually you've been in academia and in industry. So, and working with financial institutions and insurance companies. So I think and Steve, you with marketing. So I think it's very interesting. One of the things I think we should take from this is that data science touches like everything, you know, and if it's not touching it yet, I think it will, which is why we're so excited about having all of you join us and learn about this and help us build the future. So that's all I wanted to share, Emily.
That's great. Thank you so much. And it's great. And I already see people asking questions in the Q&A box. I see responses, some great questions, some great information being shared. So we're very excited to keep continuing here, which brings me to question number 2. So all of the panelists will have between 2 and 3 minutes to answer. Question 2 asks, what resources, educational or mentorship experiences were the most helpful to you in your career? Are there any organizations or programs that you would like to promote that were helpful stepping stones? So Vivien, would you like to start us off?
Sure. Thanks, Emily. So educational experiences are most helpful in my career. Because I'm a biomedical scientist, obviously having a biomedical background is important. So whatever your choice is, having a good, strong understanding of biomedical science is important. At the very minimum, a Bachelor of Science, but most of the people I work with have a master's or a PhD, or they're medics, or a combination, MD, PhD. So I think that experience is really important. In terms of computing, I did all my computing in a math and physics department, and I think it's, for me, very few in the biomedical department did that. What that did for me was give me a very detailed and structured approach to how to build programs, but particularly applications. I found when I was working in the physics department, it was very strongly related to know your computing, but application of that computing to that environment. And for me, that was key because that's what I do. I don't build theory that's valuable. I build applications that look at how you would manage and understand data. I didn't know that at the time, but I guess looking back on it, the retrospectoscope has 20/20 vision. So I guess that's pretty good. In terms of mentorship, as a woman doing this kind of work, I didn't have many mentors. So when they did come along, and I did have them, you really, sometimes you don't understand that it's happening. And I think you should reach out, but also listen when someone's reaching out to you. The head of the Australian National Genome Service became my mentor, who was actually an American. And he helped me enormously in giving opportunities and experiences. And often I didn't really understand, but he really helped. So what I would say is mentorship comes along in different forms, be open to it, and also reach out for it. And then the other thing I'd say is when it's your turn, you may be looking at us going, wow, you guys have done and gals have done all these amazing things. I would ask you to pay it forward when it's your turn, because I would not be here if it hadn't been for the people that really tried to help. So I would do that. In terms of organizations that I'd promote, there are more now than they ever were, certainly for those of us who are the underrepresented minorities. I do work with UVA quite a lot because the head of data science there is a good colleague and friend of mine that I worked with before at NIH. There is a Women in Data Science program there that is excellent. They run it's a conference every year. And they pay attention to the technical things and also the people things. And they bring discussions of all of the issues about being women in that environment. And we have panelists, discussions, etc. I think it's a really great organization to do technical stuff, but also to look at some of the other things we have to do, which I think comes in some of the other questions today. You can code, but if you can't work in a team, at least for me, I'm sure for others, you need to learn some of these other soft skills. I'll end there and hand it to someone else.
Great, thank you so much. And we're going to hand it over to Steve.
Oh, okay. Yeah, I think from an academic standpoint, what was important to me, I had a mentor by the name of Miles Megdal, who was a statistician back in the 80s, who was very involved in the marketing, in the start of marketing science, because that was the area I was in. I was learning direct marketing, and I was also taking statistics. And unfortunately, Miles had come down with cancer while he was instructing me, but he allowed me as a grad student to also teach, which I thought was worthwhile because I had taken undergraduate programs in it. And so it helped me because I was able to take over some of the classes that he was running. And I learned by teaching in some cases. So that was one positive thing. The second positive thing was I had practical requirements to be able to prove things. So I need to be able to prove things through data. And the number one thing I think you'll learn is in today's world in particular, there's truths and then there's not, okay? And data requires truths, but it also requires validation. And part of the issue we have is in the scientific community in particular, or in the data science community, there's this concept of peer review, where it's not just you doing the analysis, but somebody else checking your work. Okay. And somebody else checking your work, and having 3 or 4 or 5 different people who can give you feedback on whether or not what you've done is actually representing the actual correct findings of information. So nobody can have a real super ego in this space when you're a statistician, because you have to be able to accept the fact that other people have to be able to look at your work, because there's too many people out there who make up truths, and data should not be anything but the truth. Okay. And so we can build what we call deterministic data, which is going to be clearly a yes or no situation, or probabilistic data, where there's a high probability that what you do is correct. But in the most part, those truths are important, trying to get as close to, the best, highest level of accuracy you can. And the final piece I can talk about is anybody who's trying to get into this space, or anybody who wants to be in the space and do stuff, they really should just get hands-on and do it. In other words, it doesn't matter if you learn a specific type of software. Like I know people who learn Python, they learn R, they learn SAS, they learn various types of statistical tools. It's not what you learn, it's the practical application in the area. And then what you do is, once you've applied that and you've taken a couple of years to kind of really understand how to use a tool, think about the things you love in your life, and think about the things that make something important to you or mean something important to you, which may happen while you're doing this analysis. You may figure that out. And once that happens, if you apply what you learn to that specific subject matter, all of a sudden it becomes no work and more enjoyment. And that, I think, makes it better for everybody.
Thank you so much. And next up, we're going to pass the microphone to you, if you would like to add.
Sure, yeah, I will talk about the more practical resources. No doubt my education, especially PhD program, was very helpful, especially most PhDs get stipend and waiver of tuition, so you don't have any college debt, you don't have to worry about it as long as you can get an admission. But my PhD is really not in data science, so most of my data science knowledge is actually acquired after formal education, except the mathematics part, which is required for all the STEM related degrees. So I found learning data science on my own to be quite useful, helpful on Coursera. There are many other resources. I just didn't spend as much time on them because I found Coursera to be mostly helpful. It's having a lot of university professor taught university level courses. It also have assignments you can do hands-on. And if you pay a little bit of money, you can join a proper course and you have a batch of classmates that you can discuss problems with in case the TA and professor can't get you on time. And for practical job hunting ways, I think the software companies who also hire data scientists often do software coding tests. So all my friends in this field practice on Lead Code, which has, I don't know, tens of thousands of computer science questions that you can practice yourself before you really go for the real software coding test. And my past several companies use HackerRank to do the coding screen test. I mean, those are not how you learn coding, but eventually your learning has to be proven to a future employer through some simple test. I think Lead Code and HackerRank are the platforms where you can practice right before you can land an offer.
Thank you so much. I know a lot of the students watching, they use Coursera, all of these open, sometimes free resources that are really accessible to them, and virtual, which makes it even easier to access. So thank you for that. And Manyank, do you have any last things to add to this question?
Sure. Yeah, I agree with everything that the rest of the panelists said. Lots of great online resources available, clubs at if you're at the university level, things like Girls Who Code or Society of Women Engineers, lots of amazing opportunities. Look up whatever's in your area. I thought I would make a plug here for research experiences at the high school and undergraduate level, that those are opportunities that could be available. So for example, at the high school level, I live in Massachusetts, and here MIT runs a program called Primes that allows high school students to apply to get matched with a faculty member in the Boston area to do research on a topic of interest to you in the sort of math and computational and data sciences areas. And at the university level, if you're a college student, you can talk to the faculty members, the professors of the classes you take, any class you particularly like, and talk with them. They might have something that they could do, some kind of more directed study research, something not so much a giant class with 100 students, but maybe a little bit more of a personalized mentorship experience. Your university might have a formal program for this, like many universities call this undergraduate research opportunities, UROPs, or something of a similar name. Even if your university doesn't offer this, the National Science Foundation in the US offers a research experiences for undergraduates program, the NSF-REU program, that even if your own university doesn't offer it, other universities might offer RU programs that are open for anybody to apply to. You don't have to be a member of the same university as the one that's offering the program. So there's a variety of mentorship opportunities available for trying to get your hands into a project even early in your career.
Those are great ideas, Manyank. We'll have to look at if we can find the REUs that are available to advertise them to the Nsdc students. I have to figure out, I'm not sure how early they're advertised, like if you have to be in the know. So maybe you and I can talk about how we can find those and we can make them more available. And for opportunities like that, we actually have a program at the Northeast Hub called the REAL program, which is Research Experience and Leadership. And one of the programs that we have going on right now is our COVID Information Commons, another one of the projects we have at the Hub. And we have a student paper challenge going on. So what we can do is put the link for that in the chat as well. And what we do is you sign up and say, I think I might be interested in doing this paper challenge. It's for community college, undergraduate, graduate students around the planet. And we do monthly mentoring calls so that you can find a mentor, meet a mentor. One of the students who participated actually in the undergraduate student paper challenge we did last year for the COVID Info Commons, we call it the KIC. He was actually a junior in high school, but had been taking college classes at the University of Minnesota for 3 years. So he was also a college student while he was a high school student. He ended up winning 3rd place in the undergraduate challenge. I got information from the registrar showing that he was actually enrolled in the University of Minnesota. And he ended up meeting a mentor that worked with him, and they submitted a paper to Springer together, where he was the high school / college student was the first author, which means you're the first one listed, which is very cool. So there are all sorts of cool opportunities if you're in high school or college, or an adult learner, later in your years, and you want to retool. You heard of people saying, I was, biomedical, and I was this, and I was that, and I was in marketing, and now I'm a data scientist, right? So you can learn it too. So I think at both ends of the spectrum, there's a lot of opportunity. So just think of how you can say yes to yourself and move forward.
Thank you for that, Florence. I'm sure there are many of attendees in the audience that will find all of those pieces of advice, the opportunities, the mentorship advice, and all of those resources very useful. So thank you. So the next comment is actually a very common question that we get asked here at the Hub. And since you all have such different and various backgrounds, I'm sure our attendees will be very interested in your responses. So all panelists will answer, and you'll have approximately 2 minutes each to respond. The question is, what are the most common software tools that you use in your roles? Which coding languages and software tools should I prioritize, and why? Yu, would you like to start us off here?
Sure, yeah. So in my work setting, it's usually SQL and Python. There are a lot of libraries within Python, and there are versions of SQL, but mostly these two. I think in some settings, R is also used. R and Python are two competing languages. But in my past several jobs, I think Python has been the norm. Yeah, so when we do the interviews, we usually do not name which language, but we give a set of questions. And SQL and Python are very different. SQL is database query language, so you pretty much can only do it with SQL, but the Python type question, you can solve it with other languages. The thing is, you have to be able to code to solve some problems to pass.
Thank you for that piece of information. I'm sure everyone's writing that down in their notebooks right now. Manyank, would you like to add to that?
Sure. There's a lot of different software packages and languages that are useful for a variety of different things involving data science. There's languages that people often use when they're conducting data science, like Python and R and all sorts of things. Who knows, though, that might change in 5 years, might be something else. And then there's also platforms and systems and languages when you're like building the actual data science tools that you want someone else to use. Those can often be more systems languages like C, C++, and goodness, I hope in 5 years it's something better. But learning any of them and all of them are useful for just improving really your skills in being sort of fluent in understanding concepts rather than individual syntax of an individual language can be useful. Also, another software tool, prioritize might be a strong term, but another tool that could be helpful is just getting familiar with Git and being able to work with open source software repositories and try your hand at finding a software repository you can try to make an improvement on and submit a request for inclusion of your code upstream. So a lot of data science tools are available publicly on GitHub, and anyone can, and if you're welcome to contribute to them. But learning them first is obviously important too. So yeah.
Thank you. The Nsdc actually hosts a lot of GitHub content on our website. So if anyone's looking for data science specific GitHub content, you can find it right in the Learner Central. We'll post a link in the chat in just a minute. Vivien, would you like to respond to the question?
Sure. And I think there was a question in the chat saying, I can answer it 2 for 1. What languages do you consider crucial for bioinformatics and data science? So in my world, it's Python, very much so. Also BioPython. So I used SQL as well. And then I need a bit of help here with the pronunciation. R, the tool R. Can't quite say it like you guys. We use tools, if you're in this field at all, we use a lot of tools from what is called Bioconductor, which is a collection of R tools for analysis of genomics. And then I also wanted to highlight Git. That's a really important one for what's come up before. And in my world, we do a lot of stuff on TensorFlow and PyTorch. as well. And I just want to highlight a few other things like CMOS, which is, for those people that know, it's an open platform for a lot of genetic research, which is important. And then a few other things I want to highlight, not so much languages, but you do need to do this, I think. There is an increasing amount of emphasis on some level of standards around data. So you can code whatever you want in Python, but you need to understand the structure of some of that data. So in genomics, there's something called GA4GH, which is Global Alliance for Global Health. And it's looking at, it's a community-driven standard. There are many now developed in the bio space. So learning what those are, it affects the metadata structure and then what coding you actually apply. They also have a lot of APIs and various tools in those fields. And in the bio space, just to make sure that you don't always need to do deep coding. I have people in my team that know what an API is and know how to build one, and know how to apply it to a set of resources so they can pull data that they want. So those are kind of my collection of things. So I think the question was about bioinformatics. They're the ones I currently use. There are lots of others, but that's a kind of a general source.
Thank you. That was a great list of resources. I know Florence is writing them down. I can see her taking them notes of all of them.
Vivien, I might actually follow. We might have to chat anyway, we decided. But, there's some work we're doing with the AIM-AHEAD program, which is the NIH program for artificial intelligence and machine learning to advance health equity and diversity in research. It's a very long acronym, but they have a whole portal that we're going to be helping them leverage the Nsdc tools in. And as I listen to what you were talking about, I'm thinking that maybe we could find content or create content around, I don't know, would you say BioPy or something like that? And then you said
BioPython, and then GA4GH. It's a set of tools, APIs, services, and ways of how you handle genomic data. And also, it actually talks about some security issues as well. There are services there for data handling and security for those in the biospace. De-identification of data and privacy and security of data is really critical.
Wow, maybe we can do an interview with you and you can talk about these and we can put them on the AIM-AHEAD portal, Emily. We have ideas, Vivien.
Sure. Anyway, back to somebody else then.
Thank you. I'm sorry, back to you, Emily.
It's actually going to be back to Steve. Steve, would you like to answer the question?
Well, not to be redundant, but I think everybody's kind of said SQL, Python. Just learn, just do it. Just sit down and try to figure out, take some courses, go online. There's actually community groups that actually feed each other with different problems they try to solve, from simple to more complex. It's really interesting. My nephew competes in hackathons, and most of the hackathons in his world were programming hackathons, but there's now data science hackathons that you can compete at various levels where you try to solve problems, and they make money. I mean, they actually pay people to do these because there's corporations who want the answer to the questions. So that's interesting. So SQL, Python, R, those are standard languages that if you're in the data science field today, I'm not saying tomorrow, and I believe with Manyank saying, if you're getting to programming like C++ or C#, sooner or later, something's going to replace something else. There's going to be a scripting language or something else that's going to come out. The other thing you should know is how to communicate, and Git is one of those ways. So Git is a way to share information. There's also things like Jupyter Notebooks and other products like that where statisticians or data scientists share their code, their algorithms with each other and allow it. And then I heard, I forget who it was, maybe it was you or or one of the other panel, maybe it was Vivien, talked about things like artificial intelligence tools like TensorFlow or natural language or machine learning tools like TensorFlow. That's a little bit of a step up, but that's sort of the next step in the journey. But it's going to become more and more prevalent. Okay. And then the last thing I'm really focused on now is starting to talk about Web 3.0. And the reason for that is that security and privacy is going to keep rising to the top. My business is a privacy-driven business. I have to be compliant with state laws and standards for the communication of information about people. We deal with real people. Real people don't want their information being shared all over the place unless they give you permission to share certain parts of that data. We call that limited PII, or personally identifiable information. So Web 3.0, some of the new encryption technologies, and Manyank, I heard, talked more about encryption in terms of keeping data encrypted both in motion and rest, and other stuff are going to be part of the data science toolkit that you're going to have to learn, because nobody wants that data out and available in the marketplace without their permission. Okay.
Absolutely. Thank you. So thank you for the answers for that was question number 3. We are going to move right on to question number 4. We're going to have 3 panelists answer this question with about 2 minutes for a response. So the last question covered a lot of technical skills. So this kind of shows the other side of things. Question 4 asks, other than the technical skills, what soft skills are most important in your roles and in the field of data? So Vivien, would you like to begin?
Sure. So let's define soft skills. That does not mean soap or anything else or spongy things. Soft skills are the things that you'll need to work with other human beings. When you're doing data science, you can code alone, and that's possible. But in the world I work in, with large complex projects, you need to work in a team. You will have other team members who have similar skills to you or varying skills. And there were people in your team who don't have coding skills. So you have to learn how to work in a team and accommodate people with different skills. Someone who doesn't code isn't less worthy than you. They are different. A lot of people think that project management is not valid, but it's a very valid thing to keep very large projects on time. Project managers aren't necessarily coders, but you certainly need to work with them. So you need to work across these people. You also need to communicate. That is, not writing code. You can't send code to someone as communication. So you need to be able to communicate what you're saying to people. And that means, what are you doing in your project? Where are you up to? There's updates in that. Invariably, the problem, if there's something wrong with code, it usually doesn't have emotions associated to it, but humans do. So you can do a lot of things to code and it won't bite you back. You try that with humans, that's a whole different story. So understanding how to communicate to other people in your team, either above you as a supervisor, people who are equivalents, or people who are learning, is really important. I also think a soft skill, because it isn't coding in this respect, is also mentoring. As you come along in your world, realize that you have to reach out to others. If you've been given the opportunity to grow, give that to somebody else as you start getting some skills as well. And I personally feel that managing up, managing across, and managing down is important. Don't be a yes person. Really look at being able to answer the questions. I'll leave it there since we had 2 minutes, but I think those are some key ones.
Great, thank you so much. Would you have anything to add?
I pretty much agree. I think the soft skills, communication, and project management are generally useful. In addition, although some generic data scientists exist, but in order to make real impact, you need to pick some large areas of focus. I think our panelists obviously found their own focus. Vivien is in bio applications, and I am focusing on finance, but even within finance, there are sub areas. Very quickly, you will see when company recruit people, they might say no particular background required, but when you want to develop a good solution to the problem at hand, you need to understand the data and how they are created and what are the lingo people use, how the data are generated, and how people use it in order to talk the stakeholders' language and create a solution they can embrace. So the domain knowledge is quite important. It's not optional. It may not be that important when you enter the field, but if you want to advance and make true impact, it becomes very important. That what field that is differing by people, but eventually you should find the field and acquire more knowledge in that.
Thank you. And Manyank, would you like to close it up?
Sure, I agree with everything that Vivien and you said. I'll just put in a plug for writing. In addition to like having conversations with colleagues. How do you disseminate your ideas to the world? And I think Steve mentioned earlier Jupyter Notebook, and that's like a great way to like show your analysis and why you think it's correct, and to intersperse your scientific parts of your code and your results and your visualizations with your explanations. And that affects all parts of data science. If you're a researcher on some new algorithmic advance, you might be like the next Einstein, but if the rest of us can't figure out what you're doing, like, it doesn't really matter. We won't use your tools, right? If you're able to come up with some new way if you're an empiricist and you're looking at data and you're finding some new finding out of it, being able to convey why your way of slicing and dicing and looking at and visualizing the data is the right way to view it, especially in a world that's increasingly becoming one that it's even easier than before for people who don't know what they're doing to slice data the wrong way and come up with the wrong impressions, either by accident or the rise of disinformation and people actually using data for incorrect, misleading reasons on purpose. Being able to be a good writer and conveying why your methods or techniques or algorithms or findings are the right ways to conduct data science is very important.
Thank you. I think I heard a quote from LinkedIn the other day that said, hard skills are how you get hired, soft skills are how you get promoted. So I think it's interesting because a lot of people who come to us are even a bit intimidated about the data science field because they think it's all numerical, all hard technical skills. But I think your responses really remind us how important interpersonal and communication skills are. So thank you. We'll jump to question 5. So question 5, we're going to have 2 panelists answers just to keep with the time. So each panelist will have about 2 to 3 minutes to respond. Question 5 asks, how do you expect the data science field to innovate and adapt over the coming 5 to 10 years? So Manyank, do you have any thoughts on that?
Sure. Short answer, I don't know, and I'm very excited to find out. But I think I'll pick up on something Steve said earlier about sort of the interplay that data science has with society. And I think this is going to be increasingly an important area of exploration for both us as data scientists and in interactions and how we work with people in other areas of expertise. He mentioned, for example, intersection of data science and law, like how, when you conduct analyses on data that is personal information, how that influences what we as society have encoded through our legislature putting into laws, what balances we want with data privacy, with the privacy rights of individuals, groups, and society. So if you happen to be someone on the call who's a lawyer and you're interested in the connection with data science, first of all, hello, thanks for joining. But that's great. But also for those of us whose background is in data science, figuring out those connections and how our work relates to that is important. And it's just not just law. It's like, I just said that as an example. There's also connections to ethics, to, if you're in college, take a class on ethics, take a class on sociology, take a class on philosophy, and think about, even though the class is on a different topic, which is kind of a good thing to like get away from your data science parts of things, think about how it connects to the work that you're doing in data science, right? And how the ideas, ethics is not a new thing. The existence, my point is to say data science might be a new thing, but the fundamental fact that things can be used for good or bad is a millennia old problem that humans have had. And the fact that now data science exists, it's also a tool that can be used for good and bad. And we should be thinking about how we prioritize and promote the good parts and figure out how to, work towards a society that mitigates the harms of data science. And so I think those kinds of connections of how data science interacts with the world and interacts with sort of these humanities areas of studies is going to grow over time.
That's great. Thank you. And Vivien, do you have something to add?
So I think I got it really right. The question is, how do you expect? Well, I don't know. I agree, but I know it will. Okay. So I think that's true. Couple of things. bioethics in the bio world is going to become bigger, not less. And part of that is because the algorithms, particularly ones that are using AI, ML, but also the ones driven entirely by humans, can be quite biased. And we're seeing many, many examples of that already. One person, actually, if I can mention this, is a woman called Zeynep Tufekci. It's a very complex name to write, but she's a software engineer, and she works in social ethics of these kinds of things. And she's an excellent person to look at. She doesn't work in bio, but she definitely looks at these aspects. Bioethicists exist, but I think we're going to see more of that in this field integrating in the work that I do because of the bias of algorithms. Another one is security and privacy. So Manyank, I'm going to come and talk to you because homomorphic encryption, I think, is going to be something we see a lot more of for a lot of reasons. As more data comes out from humans, we're going to be able to identify them more readily. So you already can do that from genomic data. It's becoming easier and easier to do that. So security, privacy issues and software and ways to deal with it is going to be very important. A couple of other things. There was, I think, one issue there. Cloud is the common one. Everyone's saying cloud, right? So in the case of biomedical science, one of the advantages of cloud is you could be anywhere in the world and you can potentially collaborate. But securely sharing data between places, so for example, if you're in a different country, they have different rules. If you know anything about data security and privacy in BIOS field, you can't always break those geographic barriers, but you can certainly do it on the computer. And so what we're going to see is increasing issues of governments looking at policies around their data and what they can and can't share on cloud. A couple of other things that I would foresee is as cloud is growing, we're starting to see native services that run on cloud that are both for data management, but also for analytics. So we all know we can run Jupyter notebooks, but there's more and more applications that run within those notebooks that are for analysis. Some of those will come as native source tools from the various cloud providers. So I think all of that is there going to be a lot of effort in this field, but I think we're also going to have to exercise judgment, which is what are the best tools? What are the best tools for the analysis? What are the best tools to protect our citizens' data? And industry has a reason to exist. They drive markets. So we also need to look at, if we are going to use cloud, what is best technically, but what is also abiding by ethical rules? And I think all of these things will interplay. And I think it's going to be very important to have representation from underrepresented minorities that have their voice heard in the application of all of the things that I mentioned before.
Absolutely. Thank you. Okay, let's see. We have one question left of the panel portion, and then we're going to do a quick demonstration of some resources and then the Q&A. So a reminder to everyone to keep posting their questions in the Q&A box. For question 6 of the panel, all panelists will answer. You'll have about 2 minutes to respond. So this question comes directly from our participants. Some of them would like to know, how can they get started in this field if they have no background or experience with data science or software tools whatsoever? Do you have some advice on this topic?
Sure. I think you can look at the various data science curriculum online. It could be university program, could be online free programs, and just pick some component of each and try to gain knowledge. And a good place to practice is the various problems online you can solve, such as Kaggle computation. Like Steve mentioned, if you're good at them, you even win money. I think Netflix famously around 2000 put up $1 million to give to the top 3 teams that beat their recommendation engine algorithm. So if you don't know anything today, you're likely not going to win $1 million, but it will be a good practice. And there are a community of people who try to solve the same problem. So they post their answers and you can learn from how they solve the problem. It also gives you a pretty complete experience in handling the real life data and try to form a solution and optimize towards some goal. I think once you get over the initial bar of mastering some tools, It's all about gaining real life experience solving problems.
That's a great piece of advice. And Steve, would you like to add to that?
Yeah. I think the younger you start, the better. Because if you can start even in high school or before and get yourself oriented and determine, am I a math person? Am I a person that kind of understands how to work with numbers? Is this something that appeals to me? Particularly with STEM courses for women, there's a lot of women out there who probably have been dissuaded to get involved with this. And I find a lot of cases they're some of the best that I've met in terms of being great data scientists. So, I think there's a certain amount of bias that occurs. And so I would get involved as early as possible. So if you haven't already sort of made up your mind that this is a field you're going to be in, but you're thinking about it, just try it. Take a course. It could be a community college course. It could be an online course. It could be something that you become a member of sort of a data science club type of thing. There's whole different groups out there. You can go on LinkedIn, you can find dozens of them. There's whole groups of people and they have get-togethers. They have data science meetups, if you can believe that. So, it's things that you can do. Just get yourself exposed and experience. And once you have the experience, then make a decision of which direction you want to take in your life. Data science, a very high-level CEO of a major corporation one time told me that as a data scientist early in my career, I was going to be the guy that turned off the lights when they decided business was over. Okay. I'd be the last person to turn off the lights. And I kind of thought about that. And I said, that's really interesting because what he says is basically data science may be the last frontier of learning that is necessary because it's real fact-based understanding and it's what powers businesses and governments and corporations to move forward. So there's going to always be a need for somebody who can calculate and figure out and try to help to get the job done, be it in health or business or financial or government. It's always out there. So, and if you want to make money, frankly, it's probably the highest entry-level earning position in the marketplace. So learn it, get good at it, and you'll probably make more money than your peers trying to do other jobs in the same space. Okay? That's my thought.
I think everyone who is watching, maybe in the background, everyone's ears just perked up.
It's something I've listened and learned my whole life. And frankly, I did quite well for a period of time there. So I retired and then came back because you have to retire to something. So I retired to becoming a data scientist. So there you go.
That's great. Let's see, Vivien or Manyank, would you like to add to that?
Manyank, do you want to go first?
Oh, okay. Yeah, I agree with everything that's been discussed so far. I like Steve's advice of trying to get your hands dirty and start to use data science tools. But I'll maybe say a little bit of a pitch for the converse, not to disagree. This is not a disagreement, but also to say you can never go wrong with just expanding your sort of math fundamentals, right? Like even if you don't actively do data science, especially early, if you're a middle school student, a high school student, anything, any sort of like class that's available at your school that's about math or statistics or something, even if you don't do anything with actual data, building up your ability to think quantitatively, to think probabilistically, that way of reasoning is going to benefit you later in life if you go down any career path in or around or related to data science. People who have that kind of way of thinking, like I can teach those people who have that math background the specific data science tool that I want them to use, the specific software tool I want them to use. But if I have to start from scratch and explain sort of this way of reasoning, this mindset, it's much harder. So that's what I would say.
And Vivien?
I'm going to quote some scientists from the biospace. So Crick and Watson, who discovered DNA. Francis Crick, was one of the scientists who's involved in the discovery. He had something called the gossip test. You should look it up on Google. And the gossip test was, if you want to find out what you want to do, look at what you gossip about. So if you're interested in something, let your curiosity lead you to where you want to go. And I think that's what the other panelists were getting at. Start somewhere, but I would suggest look at what you're interested in. I started with my dad's HP calculator learning stacks because my dad was an engineer and I wanted to learn how to do stacks. I didn't realize I could do it, and it was natural to me. And I went straight from there to linear regression because I had all this data. But it was my curiosity led me there. I didn't go, I want to learn linear regression on an HP calculator. So let your curiosity lead you, and then you will learn with much more open mind and probably have fun. Some of it will be hard for sure. There's nothing that's straightforward and easy, but you'll also find out what you like, what you're good at, and what you're not good at. And I think those things are really valuable to do that. If you force yourself into doing a data science course and you absolutely hate, I don't know, linear algebra or something, you're not going to want to do that for a living. Even if you make $100 billion, which, yes, this field, sorry, Steve, I don't know how much that is, but, you know, if you could make a lot of money, but quite frankly, if that's what you're doing and you're not enjoying yourself, you generally will only do that for a few years, maybe retire and then go and do what the gossip test told you in the first place. There you go. That's my final summation of that.
Great. Thank you. Thank you all so much for all of these helpful, thoughtful, insightful answers. I've truly learned so much from all of you, and I'm sure all of our attendees have as well. So thank you so much for that conversation.
You're welcome.
Next up, we will be doing a quick presentation right before the Q&A session. Let me move the faces over.
Give me a second. The faces are in the way again.
Sure, no problem.
Sorry. Okay. I'm ready. So thank you very much, Manyank, Steve, Vivien, and you. Excellent. And there'll be more questions. Okay, I'll move the faces again.
And to everyone, as I'm going through these slides, feel free to ask questions in the Q&A box. We'll have the Q&A portion right after. So I'd just like to inform you all about a few resources and events that we host here at the Nsdc. These resources would be great for you to use if you want to learn or teach more about the world of data science. So first, we have the Learner Central. Here you can learn data science at your own pace. Whether you're just getting started or you want to learn advanced techniques, you can find resources here to help. There are resources from data science ethics all the way up to computer programming in here. So if you're looking to get started with R, SQL, Python, or more, you can visit the Learner Central to get started and practice skills. Similarly, we have the Educator Central. Here, educators can find a vast range of resources and materials to develop or broaden a data science program. You can find programs and resources here from many different institutions, including Columbia University, University of Rochester, Queensborough Community College, and more. You will also find data sets here to help create research projects or even practice questions for your students. We also have the video library, which has 5 to 15-minute videos recorded by data science students themselves using the IBM Open Data Science for All GitHub content, SQL and R educational materials created by student volunteers, and more. So you'll find videos, again, from introductory courses all the way up to supervised unsupervised machine learning and data science use cases in here. So feel free to check that out. We also have free resources for chapter and career development. If you're wondering how to start your data science career, you may leverage the Career Central, where you will find the latest job listings, resume tips, and practice materials for your interviews. We have our Chapter Central, which I will cover in our next slide. And we have our Volunteer Central, in which you can find the Hub's REAL program, or as Florence mentioned before, the Research, Experience, and Leadership program. This program offers opportunities to facilitate online events, curate resources, and more, all while learning more about data science and its real-world applications. So if you're interested in joining this program, you can go straight to our website. We'll drop a link in the chat. We'd love to have you as a part of this collaborative community. are Nsdc chapters. So the chapters extend the Nsdc's mission of creating a community of support for its members, extending it through local community development initiatives for underserved and underrepresented communities and learners. We provide mentorship and research opportunities, career opportunities, all to launch your data science journeys. As you can see on that image on the left, there are currently 12 institutional chapters around the world, and this network of students, professors, and professionals is growing every single day. So if you'd like to be a part of this network and community, you can email us or again, visit that link at the bottom of the screen. One last program I'd like to mention is the Nsdc's Inaugural Data Science Symposium. So the National Student Data Corps held its first annual Data Science Symposium this year, starting back in February. This program provided a virtual forum for students around the world to present their research and network with other data science enthusiasts. The symposium offered these participants several opportunities and resources, including mentoring sessions to assist them in designing and completing data science projects. Student teams submitted their completed projects in June, and the winners will be announced this September. So make sure to keep an eye out for that big announcement and for an invitation to a virtual research symposium to hear about the students' findings. And now we will begin the Q&A portion of this webinar. So a reminder to post your questions in the chat to have them answered by the panelists. We'll begin this session with a poll. So we're going to push out a poll. You should see a pop-up on your screen, and it'll have 3 options for you to choose. Whichever option has the most, whichever option has the winning amount, we will ask the panelists first. So I'll give you just under a minute. It's already coming and I can see it. To pick which question you're most interested in hearing the answer to.
And we tend to have a consistent winner, don't we, Emily?
We do. And it looks like that one is going to win today. Okay, so I think we can start off with, can you see those results too?
I don't know if the participants can, yeah.
Okay, so we're going to start off with question number 1 is going to be, what do you know now that you wish you knew during your time in school? So you or Vivien, would either of you like to comment on this?
Yeah, you, after you.
Okay, sure. Yeah, I guess like Emily said in the beginning, the career journey is actually not related to what you study for the most part and is not foreseeable, but it doesn't mean the journey along the way is not paving steps to the future. I guess when I was in school, I was optimizing on scores and getting graduate school admission, whatever I can see at that time. And along the journey, there are frustrations. I didn't get what I wanted to do. I feel like I took detours. I shouldn't have done some things. But in the long run, I think those things learned along the way are all helpful. And sometimes a seeming detour, come back to be very useful in unexpected ways. So I guess you should not discount any experience. You don't get discouraged by things that you feel is not going well. Maybe the difficulty you encounter point you to a weakness in your abilities or aspect of yourself you don't know, or is temporary, that if you overcome that, it will just make you so much better later on. One particular example in my case is I was a professor for 4.5 years, and I was proven to be not such a great teacher, and I wasn't particularly loving research either. So I feel like I could have gone into industry and just shave a few years of my journey. But later on, when I was in New York, a hedge fund was looking for a data science teacher. So that's how I got the position. It is very strange. I got a hedge fund job because I was a teacher and I was practicing data science. So you never know which part of your life journey is going to help you later.
Thank you. Does anyone else have anything to add to that?
Yeah, I totally agree with you. So detours and cul-de-sacs, if we're going to use that, are exactly what you need to do. There is no straightforward way to do this. I often use the term with my team or people I talk to. The retrospectoscope has 20/20 vision. When you look backwards, you will be able to see things clearly because you've had so much experience. But when you're actually going through it, you don't have any idea how it contextually fits for a couple of reasons. You don't have enough experience in the world. And at least for me, and probably a few others, no one else looked like me when I was going through school. So there was no path. It was this kind of like, I don't know how to do this. So again, I followed what I was interested in and I discovered what I was good at. I discovered what I was not as good at. I think what you was getting at. But those dead ends or cul-de-sacs, detours, whatever, helped me understand, okay, well, I don't like that. I'm not good at this. And then you find ways around it. I think exploration and recognizing that this is a journey all along, that you will hit dead ends and they're going to be hard, but they will teach you, is exactly where I look for people, critical thinkers who realize that they've learned from their life. Also, failures are not failures as an endpoint. Failures are what you need to do to be able to get better. And I think that trying to have a look at all those pieces every time that something like that happens, look at it as a state of where you want to go. Look at Yu's story, right? You were teaching and then you ended up there. You know, I was hacking into a bio database from a US-based system when I was a PhD student, and I got a job at the Human Genome Project. So, you know, here I was hacking away at it just to learn how to do something, and I ended up getting a job in the United States. So serendipity plays a huge role here. And so keeping an open mind is really important. It's also going to make you curious and far more interesting to employers that if you just go down, I know how to code everything in Python, becomes quite meaningless. So stay curious. Hope that helps.
I think it does. As a recent graduate myself, I think that it is intimidating to think of like the barriers in front of you. And again, as we mentioned in the beginning, a lot of people think it should just be 1, 2, 3, right out of high school to college to data science to this big job. You know, there's this idea about that in this field, and just hearing how it can come from so many different places and there will be bumps, but to keep thinking and to keep going, I think that's very inspiring. So looking through some other questions, I think this one's pretty interesting. Was there ever a time when you felt unprepared for a role that you were applying to, and how did you handle that? So whoever wants to jump in, I'm actually very interested to hear Steve's response because he seems to have a ton of experience going from different roles, retiring and then coming back. Have you ever felt unprepared for a role you were applying to, Steve?
Hubris-wise, no, but in reality, yes.
Okay.
And I was going to make the comment, hearing what you and Vivien said before, I'm listening to that and I'm saying to myself, okay, you know, I was never the best coder or the best analytic statistician out there. I mean, I could do my job. I understood how to do it. What I was really good at was selling what people produced. So I became a subject matter expert as my course and direction and path, that I could digest and dissect the data science, but I could explain it to the non-scientific person who literally was part of the sort of general community who needed to understand why this was important to them. So I took a different path. I still spent time coding just to keep myself up to speed and learn new code and new software. But I really spent most of my time, because I was able to surround myself, luckily, with people who knew how to do this and really didn't want to talk to people. They kind of like to talk and look at their computer and be heads down. They really weren't that much into being face to face with big crowds. I would stand up in front of 5,000 people at a conference and say, and this is the reason why we need to do this type of thing. Okay. When I was at IBM, I had a big quota that I had to sell because I was selling data science. I was a senior partner in ad tech, martech, and cognitive analytics at IBM, and I had to sell things like Watson, which at the time we were still trying to figure out even what it was. I mean, it was a bespoke program that won Jeopardy. Okay, it didn't necessarily always have that adaptability to become something that could become part of the mainstream data science world, and so I had to make it up as I went along. So yeah, there was times when I was unprepared. I would go into meetings thinking that I had all the information that I wanted and find out during the course of that meeting, I kind of had to, jib and jab a little bit and zig and zag because, I didn't have all the answers to the questions. But and in many cases, it's okay if you say, I'll get back to you. Okay. It's not awful. But it's not always the best tactic when you have people in front of you who are very type A and insistent to say, I want the answer now. Why aren't you giving this to me? So I went down that route of data science. I went down the sort of executive presentation, selling the concepts, being the subject matter expert. But there's plenty of people in data science, the vast majority of people in data science, who just really enjoy sitting down and trying to figure out the answer to the question. And, I respect them just as much as anything that I did.
That's great. Thank you. And does anyone else maybe have an answer to that question?
Can you restate that question, Emily, just so I can remind myself? It's the end of Friday and my floating away without enough coffee.
Sure. So the question was there ever a time when you felt unprepared for a role that you were applying to, and how did you handle that?
Well, I feel like that all the time, but that keeps you sharp, right? Also, because I'm trying to do so many different things. I think, do I feel underprepared at times? Yeah, but it makes me want to learn more. If you think you know it all, maybe you do. But usually when you do that, and I've met people like that in work, they usually don't. And the other thing is, it's a team sport, not a contact sport. So if you think you know it all, then you won't leave space for your team members to actually provide information that you need. So being prepared often means that you work within a team. I used to be a team member when I do that. I'm still part of a team. I now run teams. And I actually push that ethos. When I get someone that says they think they know everything, invariably their code will fail somewhere along the line, or they won't have thought of something. So knowing that you don't know everything is pretty good. So I'll quote somebody else, Socrates this time, okay? Knowing, wisest is she who knows she does not know. I use that for my PhD because when you realize you don't know everything, you'll be prepared and your mind will be more open to hear other solutions that you probably wouldn't have done if you thought you knew everything. How about that? That's philosophical. That's pretty good for a Friday afternoon.
I can give a quick comment from the interview perspective. So there are a huge amount of data science positions, and if you're greedy, you just apply to them all, and sometimes you can get some interviews. And some of them are really not good fit for you. So that's how you go to interview. You feel you're unprepared or they don't even call you at all. So maybe that means you should narrow down your search a little bit. But for other positions, when you similarly think you're a perfect fit and you still couldn't pass the interview, I think for the most part, there are just so many applicants because applying is easy. And the recruiter or the hiring manager has to select one from so many. So they just artificially lift the bar higher. Mm-hmm. It doesn't mean among the people getting rejected, they cannot do the job. I'm pretty sure for every offer we give, there are 10 who can do the job. And once you're hired, the bar becomes lower. If you are not good at one thing, you're given time to learn that. And everyone are given plenty of time to catch up. So if you have the right attitude, you will eventually catch up. So just because you couldn't pass some interviews, well, it's a good learning opportunity and you should practice your interview skills, it doesn't mean you can't do the job. Be courageous. Some people are just more confident than the others. When they get rejected, they feel, oh, it's their loss, it's not mine. And other people might just feel, maybe I'm not qualified. I think female is more likely to feel this way. But it's not that you can't do the job. Maybe you just need more practice at interviews.
Agreed.
That's all such great advice, Steve. Maybe we'll ask you to do a little expert class on confidence or something like that.
Well, it's never been something I lack per se, but it's always usually backed up with a little bit of solid knowledge across a broad field, and then some ability to be able to, do stuff without necessarily having all the facts, but knowing how to put what you have together and presenting. That's all.
That's
So
great
it's,
advice.
and frankly, you don't have to be a socially superstar, in terms of being able to get out in front of everybody to be a great data science. Most data scientists are not social, people. They tend to be much more introverted, and a lot of the people I work with are incredibly intelligent, incredibly capable people. They're not big on presenting. Okay, I can take their work, they explain it to me. I try to understand the best way I can, and then I go out and present it. And together, and as Vivien, I think, keeps on emphasizing, it's a team. You can't do this by yourself. There's too many people have pieces of knowledge in this that make it worthwhile.
I agree. That's great. And we have to thank you before we wrap up. We're going to ask one more question, but I have to tell you, you are the best answering the questions panel we've ever had. We've had 31 questions in the Q&A. And I'll say, this is a good one. And then Steve, I'm like, he just answered it. So if you've been asking questions in the Q&A, just open it up and go to the answer side. And it's really been great. You've all been so wonderful. But one last question before we wrap up. And I know Steve already answered it, but there may be some other answers. What if you've tried out data science and realized that you enjoy the people interacting, storytelling aspect of it, currently figuring out what roles are out there for people who fall into this category? So any thoughts on that? There was actually a gentleman that came to the Nsdc, and he was a serial entrepreneur, been in business for years, was looking to get into data science, retool himself, not a programmer. And so one of the things we talked about is getting into data visualization, because if he used data visualization tools as a business person, he could tell it looked like it was making sense or not, or what it was saying to him. And he ended up getting an internship in that, which was great. So any other comments you have for people that are saying, I tried it out and I like that of the people side, the storytelling side? Any comments beyond? Steve already answered it in the Q&A, but any other comments anybody wants to add?
I'll add 2 comments for people who like the people side of data science. One is journalism. Journalism is increasingly becoming a data-driven field. Large news organizations like the New York Times and whatnot hire data scientists to try to visualize, to show that, to create stories out of not just anecdotes and not just data, but putting the two together and understanding the data adds context to a story about people. Another is policymaking. We talked a little bit earlier about sort of the fact that data science is going to interact more and more with society, and I mean, silly statement, data science is already about understanding properties about society, but it's going to interact more with other aspects of society like ethics and data privacy questions and policy questions about what are the good and bad, right and wrong, whatnot, ways of conducting data science and ways that we want to live in an artificial intelligence society. And there are lots of openings, lots of demand for people who understand data science and can understand sort of these policy aspects of it and can explain it to folks like lawmakers. There's programs such as Tech Congress, which is a program that pairs people in the sciences with becoming a staffer for a member of Congress and being able to describe scientific concepts to them and to help them inform their legislative activities. And that's just one example of many. So, yeah.
Wow, that's amazing. Well, I've learned so much today. Thank you so much for sharing all of your knowledge, expertise, experience. Now I'm going to try to do this correctly and hand it back over to Emily so we can do our thank yous.
Yep, thank you, Florence. So that wraps up our August Data Science Career Panel. I'd like to thank all of the panelists, Manyank, Steve, Vivien, and you for sharing their experiences and their expertise. We all have learned so much from this conversation. I'd also like to thank our outreach team for helping us put this event together, and the moderators and facilitators of this event, including Florence Hudson, Lauren Close, and Jeremy Prasad. Hi, Jeremy, who will be writing up a blog post summary of this event. So thank you all for your efforts. And then on the next slide, lastly, is a reminder of how to connect with us. So join our mailing list to receive updates and news about new events, programs, challenges, and more. Follow us on social media, including LinkedIn, Twitter, Instagram, and YouTube to keep up with us and new opportunities. And join our Slack channel to find an interactive and collaborative network of data science learners and enthusiasts, including all of us. So we'd be happy to have you there as well. If you have any questions, please feel free to email the Nsdc HQ team at that email at the bottom of the screen. We really hope that you enjoyed this event as much as we have, and we will see you next time.
Sounds great. Thank you so much, Emily.
Thank
Thank you.
Thank you to our panelists and everyone who joined us. Have a great and safe weekend, and we'll see you next time.
Take care.
Thank
Bye.
you. Bye-bye.
Bye.